Good afternoon to our participants joining in India, and good morning for those ones joining from Germany. On behalf of the Indo-German Energy Forum Support Office, the IJSO, I'm pleased to welcome you for the first webinar of our series, Pathway to Low Carbon Industry. In cooperation with the German Energy Agency, DENA, and the Indo-German Chamber of Commerce, we have organized this webinar. As I said, two more are to follow, and if those dates have not been shared with you, we will share them later on after this webinar. So we really thank you for your participation, and we hope that you will also join further sessions in this. In terms of maybe just a slight context setting, I think it's fair to say that countries around the world all work towards ambitious climate and energy goals. And I think nowadays those goals seem to become even more ambitious with all what's happening in our global sphere. So at the end of the day, I think it is fair to say that the industrial sector remains central to all of this transition. And improving energy efficiency, as well as accelerating industrial decarbonization, are therefore essential for achieving the sustainable development and net zero ambitions that countries have around the world. So through IGF, we seek to strengthen this cooperation by facilitating exchanges like we're having today. So basically that's exchanges between knowledge partners, between the industries, sometimes between political partners. And what we want to achieve with that is we want to strengthen, of course, the discourse, but we also want to make sure that practical experiences are being shared. And this is what's happening today. So today's webinar is focused on energy service companies. Many of you have joined in. Thank you for that again. And through this webinar series, we aim to create a platform for this dialogue, as I said, both with industrial leaders, but also with policymakers, which represent the industry, which represent politics both in India and in Germany. Having said this, I would one more time like to thank all of our speakers, you participants who have joined us today, and all of the partners present. With this, I would like to hand over to you, Shivani, to give some remarks also for the Indo-German Chamber of Commerce. Thank you.
Thank you very much, Daniel. Good morning to all the participants in Germany, and good afternoon to all the participants from India. It is my pleasure to welcome you on behalf of the Indo-German Chamber of Commerce to the first webinar in the Pathways of Low Carbon Industry series. The transition towards the low carbon economy presents both challenges and opportunities for the industry. Companies today are expected to improve competitiveness, manage energy costs, meet sustainability commitments, and respond to the evolving market expectations. The Indo-German Chamber of Commerce has a long-standing commitment to supporting business cooperation between India and Germany. We see tremendous value in creating platforms where industry stakeholders can learn from international experiences, explore innovative business models, and identify practical solutions that can be implemented on the ground. In today's webinar on energy service companies, experiences and best practices from Germany and other international markets will be presented. Therefore, we are pleased to bring together experts from different backgrounds to share their perspectives. We encourage all participants to actively engage in the question and answer session later. I would like to thank our partners, the Indo-German Energy Forum and the German Energy Agency, DENA, as well as the speakers and participants for making this event possible. Once again, I would like to thank everyone for joining today. And now I would like to hand over to our colleagues in DENA, who will guide us through the webinar today. Thank you very much.
Thank you very much, Daniel and Shivani, for your kind words. On behalf of the German Energy Agency, I would also like to welcome you panelists, organizers, and of course, participants to this webinar. Before we start, a few housekeeping rules and explanations. Please use the question and answer function, which you find on the top right-hand side of your screen to address questions to the speakers. If you would wish to discuss the presentations, then please use the chat function that you find left to the question and answer symbol. And the presentations of the speakers will be shared to you directly via email after this webinar. So please be ensured that you will receive the presentations. Our presenters today are Dr. Carsten Lindloff and Michael Pietzner. Dr. Carsten Lindloff holds a degree in urban planning and has worked at the German Energy Agency since 2011 as a team leader for energy efficiency policy. He has advised on ESCO market development in several international projects, including Kazakhstan, Turkey, Iran, and Jordan. And he will provide us an introduction and overview of international ESCO market developments. Afterwards, Michael Pietzner, who is the head of project development and sales at the energy service provider E1 Energy Management, will take over, and he will dive deeper into the practicalities of M&V approaches. He has over 20 years of experience in planning and implementing contracting projects, particularly in applying M&V principles. And he's also active in the German Association of Energy Service Providers and is a collaborator with DINA in several projects.
Well, good morning also, or good afternoon also from my side. I will try to give you some input on measurement and verification approaches on energy performance contracting projects. And well, basically, first thing is very basic, how energy performance contracting works for those who are not familiar with the concept yet. So the contract idea is that one company, an ESCO, goes on site into a facility, makes an evaluation of the existing situation of the energy consumption, energy cost of the equipment installed, and then proposes energy conservation measures in order to reduce energy consumption and cost. And usually he pays upfront for the investment he makes and will be repaid by the guaranteed savings he guarantees over the term of the contract to get his money paid back. So, and in this concept and process, we have two important parts regarding measurement and verification, because one part is the energy baseline, which is mandatory to have a solid figure against which the contractor proves that he has achieved the savings he has promised and guaranteed. And once the contractor has implemented his ECMs, he needs to provide energy reports to show that he has achieved a lower energy consumption or and subsequently reduce the energy cost. And in this way, energy data are a very important part to ensure the success of an energy performance contract project. So in general, energy performance contract can be a tool to implement solutions in accordance with the energy management process as described in ISO 50001. Which is a clear path and guideline to plan and implement energy conservation measures. It's not only organizational it's an organizational process, and for me, one of the benefits of this process is that it is clearly highlighted that in this process, it's not only the technical staff of the facility he needs to implement this process, but also it's the management that must be included in the process development. And I think that's that's the one part that ensures the sustainability of this kind of process. So, and that energy performance contracting is making also use of the PDCA cycle of the ISO 50001. So plan, do, check, act. So the contractor comes in, does a study, plans measures, implements the measures, trains the personnel on site, the facility management people. Afterwards, he has to check whether he has achieved the goals he has set for himself. He needs to take corrective action if necessary. And on this part, data or energy data are a very important part to see whether he has achieved his goals or not. In some cases, he might also be able to take preventive action. And afterwards, he can see if he can optimize the process, if he can further reduce the energy consumption, and that's the main part of this cycle. If I look from a customer's perspective on an EPC project, situation shows itself as follows. As a customer, I should have knowledge of my energy baseline and existing situation of the facility, of the equipment installed. I should know technically and energetically regarding energy consumption and energy cost, where I'm standing. And if I want to go on the path for decarbonization, I need to evaluate my options to reduce the energy consumption. And once I've reduced the consumption, I can adjust the energy supply side to go to a decarbonized energy supply. Well, usually this is not, I make one plan and then I implement it and then I'm finished. It's more like a process, and it makes sense to develop a master plan, a roadmap towards decarbonization based on financial and human resources, because it's clearly a process. If I want to do this the most economical way I can do. And then I can evaluate my options, whether I want to implement energy conservation measures through conventional options, projects without savings validation, or if I do it with an EPC project. This could be an EPC project regarding single measures, or it could be also a project that has a more overall approach on savings measures that could be provided in all areas of consumption. And of course, in the end, if I go on an EPC project road, I want to have a validation of the project results. So each EPC project needs a measurement and verification plan to ensure and to validate that the savings projected have been achieved. Crucial part in this process is that it should be a proven plan that will be used to validate and prove the savings suggested. And from my perspective, it makes sense to make use of the International Performance and Verification Protocol, the IPMVP. I don't want to go into the details about the organization, but this protocol gives some basic descriptions and quite simple and straightforward descriptions what should be done for an EPC project. So core concepts regarding measurement and verification regarding EPC project is each project needs to have a baseline period, which clearly defines the energy and/or water use before efficiency measures are implemented. Usually this project should be at least 1 year, or if there are changes over the year, it should be the average of several years. Second, after implementation, there should be the reporting period. Basically, it should also be 1 year in the same period as the baseline period. And of course, we all know that energy consumption in facilities is changing all the time. So there need to be a process description how to adjust the baseline or the reporting period to account for changes in external and internal factors like outdoor temperature, production levels, to model what energy use would have been without the changes. And the simple savings equation is savings are the baseline energy minus the reporting energy adjusted to the changes that have been happened during the period. Basically, the IPMVP provides 4 options for measurement and verification. I'll go quickly through them. Option A is the option of key parameter measurement, which combines engineering calculations with spot measurements of key parameters. And one of the simple methods for which it could be used is the implementation of a lighting retrofit. Now, I implement maybe thousands of lighting panels in a facility, and I can't provide a meter for every lighting equipment or every rack where lighting is going. So I could make a spot measurement of the lighting panel. And if I have implemented, for example, LED tubes and which should have lighting consumption of power of 18 watts, then I can make a spot measurement to validate, okay, the system really has 18 watts, and to define the energy savings in kilowatt hours, I can can use historical data, how many hours the lighting system will be in operation throughout the year, based on whether it's 1 shift operation, 2 shift operation, whether I have daylight influence in the facility or not. And then I can implement the figure how many hours per year the lighting system will be operating. So it's an estimate based on data and engineering judgment. And subsequently, I can multiply the wattage with the hours, and then I have the savings in kilowatt hours. Then option B is called all parameter measurement. So which, if I go back to lighting, means I would perform continuous measurement of all key parameters throughout the reporting period, and then I can determine my savings this way. Well, lighting retrofit or maybe airlink unit retrofit of fans could be typical savings measures where this methodology could be used. It needs more equipment and more time than option A, and can also be used, but in all truth, I would always prefer option A or mostly prefer option A to option B, because it's less time consuming, costs less money, and is in my opinion accurate enough to validate predicted savings on simple energy conservation measures. Option C is the whole facility option, which uses whole facility energy or utility meters to assess the overall energy performance of a whole facility or maybe a building, and savings are determined by measuring energy use at the facility or sub-facility living. So of course, this is the most accurate methodology to validate savings. And it's one that, from my point of view, should be used for most kinds of saving validation, especially if I do things like heating retrofits on a facility level where I don't know where the savings completely will come from. So for the baseline, I could use the reports from the energy or utility supplier, which at least provide the annual consumption of a facility, which could build my baseline. And then I have afterwards the option to use the meter to validate to measure the future consumption, and by subtraction I have the savings achieved. Of course, this is the methodology where I most likely need to make adjustments. Talking about heating validation, I always will have the need to adjust for annual changes in the weather by using heat degree data. What also can be done in addition to option C of the whole facility is I could use submeters and install them as a contractor to prove on measures in only single buildings or single systems like NLink units. I could use submeters to measure the future consumption and use submeters to validate calculated savings. Option D is called calibrated simulation and is a methodology which should only be used if there are no data available for the baseline of a facility to build a theoretical mathematical model of the facility. And once I do this, before implementing the retrofit, to build a baseline, I should also use this model to determine the savings and to validate the savings implemented. This is a situation I think that should only be used in very few cases. So if I develop an energy baseline, I've listed here which parts of energy could be implemented. So this could be heating for a building or a process. And if I talk about energy consumption, also the demand could also megawatt or kilowatt hours peak could be crucial for determining the energy cost baseline. And besides heating, I usually use electricity, and in the baseline yearly, it's interesting to know the total electricity consumption, and in some cases also which part of the electricity consumption goes into cooling, which into compressed air. And there might also be a project where water or wastewater could be a part of the project. Subsequently, I have energy prices for heating, consumption, and demand, electricity, and water, wastewater. So if I develop an energy baseline, some general considerations for the beginning. Data need to be for a specific period, as already discussed. So basically, it should be for a year. when the consumption of several years varies significantly without known reason, the average of these years could be taken. In the beginning, data should be available at least monthly. If not available annually, will suffers, but the more detailed the data are, the better the situation is also for making savings calculation for the ESCO. And if I take data from installed meters, I should always compare them with data from the energy bill to validate that my meter readings have been correct. Regarding heating consumption and cooling consumption, data should be always corrected by heat degree data and cooling degree data to ensure that I can compare data of 1 year with future data for another year for the savings. Well, energy demand, if it's applicable, should also be for taken into consideration for a specific period, and these data could be derived from the energy bill or could be read out from installed meters if there are any installed data, and you have insight and access to the meter. The energy prices, from my point of view, to build the energy baseline could be derived from the latest energy bill and then should be used to build up the energy baseline by multiplying consumption or demand with the cost. And these energy prices should also be used to determine the energy cost savings by the ESCO, so that changing energy prices don't have any influence on the energy performance contract. If I develop an energy baseline and want to determine further up savings achievings, some thoughts up front. Are already submeters for systems installed in the building? Does a building management system or energy management system collects the data and stores them? Should also be answered the question, are there meters installed and what do they measure? And is a meter scheme available? Well, because submeter data help building a solid baseline and enable to calculate, estimate more accurate savings. And they also ensure that an ESCO cannot overestimate his savings. And if no submetering is available, then the ESCO should develop a methodology to determine his baseline for single measures like handling units to have a solid baseline for estimating his savings. Well, coming from general thoughts to practical examples, what you see here is an energy baseline regarding consumption and cost, including electricity, heating, water, sewage water, and you see the specific energy prices used to calculate the energy cost baseline. You see the energy consumption use for electricity, for heating, and for water. And if you put this into a graph, you see easily that the electricity costs are in this case the main part of the energy cost, and heating is a completely less substantial part. But question is now, where does the energy go? If I talk about electricity, this is another example, not the same facility, but now I'm looking from the perspective as an ESCO, and I would like to know where the energy is going, so that I can see where should I start with thinking about energy conservation measures. Well, in this case, we have tried to determine where the electricity is going. So in this case, it's going in quite a lot of Erlang units are operating. I have a compressed air system operating. I have a lighting system. I have a cooling plant. I need electricity in some case for heating. I have a commercial kitchen in the plant. There is some consumption going into social spaces. And I know that basically nearly 50% of my electricity consumption goes into production. So, and if I'm not a very specialized ESCO, I usually won't go into optimizing production machines. So my area of operation would be handling units, compressed air, maybe lighting retrofits. Maybe I can do something on cooling too, but it will not have a very big impact. But I now have a clear idea in which areas I could try to implement energy conservation measures. And also, I would like to know what is my not only my annual consumption. I would like to know what at least the monthly consumption is, so I can see is there an influence. I could see, for example, do I have much electricity consumption only in summer, or is it more or less constant throughout the year? And in this graph, we have collected data on electricity consumption and the peak demand, and I could see that in summer I do not only have a higher consumption, but I also have a peak demand. And I can derive from that I most likely will have a significant electricity consumption in summer for cooling down the building. And also the load curve, which in Germany can be achieved by asking the energy supply company to provide these 15 minutes data. I can also evaluate them. And in this case, we've tried to put them into context with a number of customers in this shopping mall to see if there are any interdependencies between these two parts. If I have a baseline for heating consumption, I also want to know what's the monthly heating consumption, and I can put also into consideration the average outdoor temperature to see if there's a clear correlation between heating consumption and outside air temperature. And in this case, it's not always a consistent load curve. For example, if you look into the consumption of December of 2007, and I see that I have the lowest average outside air temperature, but not the highest energy consumption. And I need to ask myself, why is this the case? Maybe it's the center closed during several days this month, or are there other reasons for this? Regarding cooling, I can also make a comparison of outside air temperature and cooling consumption. And I need to ask myself, why do I have a higher consumption in May and June than in July, where I have the highest outside air temperature? What's the reason behind this? Is there a need for adjustment of the control systems, or maybe is there a dependency on the number of customers in the shopping center, or and I need to collect supported data for developing ACMs and saving systems. I need to know what the data of the central cooling plant, of the heating plant are. So what is the installed capacity for cooling, for heating? What are the operating times of the building, of the areas supplied? And to build up a baseline for main consumers, we have collected a lot of data. In this case, there were some data were metered, some data have had to be estimated. And subsequently, I can see where my energy is going, as already discussed, and then can decide where I should start looking for energy conservation measures. And if I visualize this, it makes things easier sometimes because I can see where the energy is going. And if I'm talking about handling units, which are installed in a lot of facilities, usually I know from the machine, there's a sign providing data about the supply and return airflows. I might know from the sign on the system the installed cooling capacity. I will see is a variable speed drive installed, is a heat recovery system installed. I know the power of the fans. I know the operating time. Usually, I will know the operating time of the systems, and from this I can calculate the electricity, heating, and cooling consumption for each handling unit, and then I can up all of them to have the total consumption of electricity, heating, or cooling for handling units. And now I have a baseline from which I can calculate savings on handling units.
Michael, could I remind you of the time so we can have a short question and answer session? Thank you.
Yeah. Just a few more slides on the use of meters and submeters for measurement and verification. In this case, for electricity, we have built a baseline, an average over several years from the meter, and afterwards we have measurement after implementing the energy conservation measures, and subsequently from the difference between those meters, the energy consumption savings multiplied with the energy prices, we have the energy cost savings. We could use a similar process for the heating consumption, and this is also the use of meters. But we have built up here, each of these columns shows the consumption during the last 12 months. So we don't only have the baseline, but we see each month where the energy consumption is going. And as a contractor, I also see, am I on the right path? Have I already achieved my savings? Do I need to take countermeasures if I haven't achieved my savings 1 month? So I don't need to wait till the end of 1 year to determine whether I have achieved savings or not. And I could use this also for adding up consumptions of multiple buildings to see, am I on the right path? And because we're talking nowadays also about implementing new supply system using other forms of energy than before. For example, here we have, in the past, we had a cogeneration plant in gas boilers in operation for providing energy for heating purposes. And as part of an ESCO project, now a heat pump is installed and should take over most of the consumption, most of the production of heating. And I want to know, is it well going? Is the heat pump included in the process as I have designed it? I want to see maybe the same for buildings. Where do I have my energy savings achieved? And if I include photovoltaics, I want to see, are they providing the amount of energy, of electricity as predicted? And well, that was a quick ride through. I hope I was helpful for you in case, and I'm open for questions from your side now. I know that this has been a very quick ride, so don't hesitate to ask questions.
Thank you very much. Yes, and I would like to repeat what Michael just said. Please feel free to ask any questions, and we will try to answer them. You will see a question and answer function on the top hand right of your screen. To kick things off, Michael, could I ask you, because you were speaking about measurement and verification, what do you typically find are the main challenges that small and medium-sized enterprises encounter regarding energy measurement? Is this data readily available?
The basic situation in nearly all facilities is there are the meters from the energy suppliers, and I have usually at least basically the data from the annual energy bill. So that's why I've put in so much input in my description about building up a baseline for each type of energy conservation, because this makes a clear process. In the end, I have a baseline for one kind of energy consumer, and from this baseline as an ESCO, I can determine my savings, and I'm pretty sure I make valid with this way that I don't overestimate my savings, because I can easily calculate savings. Let's say for an air handling unit, it should operate the whole year round, and it operates with full speed, so with the full power of the fans, and from there I start my savings. I calculate I can make 50% savings. Let's say I have calculated 100,000, 50,000, and so I have 50,000 after implementation of the ECM, and afterwards I start my measurement period, and I see, I still have 70,000. Why do I have 70,000? I don't know. Mm-hmm. Or I have only 10,000 afterwards, and then as a customer I would say that can't be possible, that you have saved 90% of electricity. So I avoid all kinds of questions.
Thank you. I don't see another question yet, so I may just ask you another one. Are there any other things that you request industrial customers to bring to a first meeting? Maybe should they prepare anything else than their energy bills?
Well, they should be open for questions, and to build up their mind, what they want to achieve by an energy performance contracting project. Do they only want to reduce their energy cost? Do they want to decarbonize their facility? Do they have any idea how much of their budget they could spend as additional input into energy performance contracting projects? And what's, from my point of view, mandatory for success of implementing an EPC project is that from the beginning, the top management is involved in the discussion. Because if or at least the CFO is included in the discussions, because if only technical staff is working on this project, it's doomed, because everybody else from the facility comes in the last minute and is not very likely to approve such a kind of a project, because it's a completely different approach than the single project approach of replacing boilers, replacing cooling systems, implementing a new fan, etc. Because it's a whole facility approach, usually including all kinds of system working together.
Thank you. Yeah, the decision makers surely should be on board. Since I don't see any other questions, dear participants, please feel free to address them while I hand over to Karsten, and I'm sure Michael will then try to either address them in the chat directly, or we can also try to answer them via email afterwards. Thank you. And with this, I will hand over to Karsten, and I hope the technical challenges have been solved. Karsten, you're still muted. And I see you are starting.
Karsten, we can't hear you.
Now I can hear you.
Yes, it's okay. 1 second. I start again from the beginning. Michael gives us some deep input from the founder of the ESCO on going out to the political instrumental level, how to create.
Could I stop you for a second? Could you maybe make sure that your microphone is maybe a bit further away from your mouth, or there's some...
Okay, it's better now.
No worse. Maybe a bit further away.
Oh, now better?
A bit better, yes.
Okay, I can also change the micro set again, but...
It's better now, thank you.
Okay, excuse for... Yes, I will go quickly into the instrumental of ESCO market development, and will show you some examples of international experience from German side, but also from other countries, which we saw in the last decade in several projects. Yeah, firstly, I want to present shortly the German Energy Agency, a public company owned by the German federal government. Normally, about 100 projects at the same time, with around 700 employees. This comes from over 30 nationalities, and we are active in data in 60 countries since our founding, and our founding was in 2000 as a quick overview. And what we do, both consultancy and strategy advice, studies and analysis, project development, market development, networking with stakeholder tools, and communication. I'll start with a short introduction into one project that I run in the German context. It goes to EPC, energy performance contracting in public non-residential buildings. In this project, we support in the moment 26 demonstration projects across Germany with about 500 buildings, on behalf of our funding of the Federal Ministry of Economic Affairs. And the amount of these projects is about 10 million euro baseline. And what the requirements for participation in this project was that the single buildings or buildings has to do EPC qualification check that we support from there, and in the yes, we talk about public buildings, and it was sometimes necessary that.
Carsten, I'm sorry, I hear that you are still not audible for some participants. Can you maybe change the headphones again?
Okay.
I think the quality was better.
So, do you hear me now better?
Now it's clear on my side, yes. Thank you.
Okay. Now how to come again to the... You still see the slides?
Yes, thank you.
Okay. So I have to change to my paper. So again to the slides. Yes. Another thing we do in the DENA's Competence Center for Contracting is the preparation of guidelines to the market in Germany, to the more overall energy performance contracting, but also to the special situation in municipalities who wants to do such contract models. I come to the basis, but I go further because Michael gives us an introduction what is ESCO in detail. I start with this slide. It shows an overview to the estimation of energy saving potentials by different instruments. And you see here that energy performance contracting, if it is done, it is more efficient than only audits, only consulting, and only energy management systems. So yes, and the potential in Germany is about 137 terawatt hours a year. This is a big amount of energy we could save via energy performance contracting. In this slide, you see a consulting roadmap by an ESCO Siemens, in this case from the Turkish market. And you see energy performance contracting is not in the beginning of the process of consulting services, but comes after the training of the staff in energy management, doing or introducing an energy management system, doing detailed energy audits, and then if you see what measures are worth to implement, you can start this with energy performance contracting. The contracting market participants are not only customers and ESCOs you see in the middle of this graph, but also you have to look to the energy suppliers, in Germany mostly municipal utilities. Then you have facilitators, for example, energy agencies or consultants who does certain work in between. Then very important are the financial institutions like banks, public funds, private investors. And sometimes you need also subcontractors, suppliers, like manufacturers, suppliers, insurance companies to run a successful ESCO system. And in a country, you need all these stakeholders to run a successful ESCO market development. This I said because we have several barriers for energy performance contracting in comparison to normal energy efficiency measures. Somehow we have information barriers like insufficient information about energy use and energy efficiency potentials. We have a lack of awareness about ESCO system and the added value of contracting. We have organizational barriers like long contract periods, complicated contracts, risks associated with the projects. We have financial barriers like credit limits and burden of balance sheets in the companies or the institutions. Then the access to financial support programs, the competitive investment opportunities, and it is difficult to have long-term contracts, especially in the private sector. And at least at the end, we have also regulatory barriers, especially in the public sectors. We have budget rules and public procurement regulation. So all these things we have to keep in mind when we start a project. And we also have risks. The central risk is achieving the expected energy savings and the associated financial targets. And other risks are, for example, the utilization risk, technical performance risks, risk of changes in energy prices, credit risks, business risks, the ownership risks, and risk of default of one of the involved companies or institution. These all you must have in mind if you want to develop an ESCO market. It is not very easy, but we have successful examples in the world. Yes, you need to develop a contracting market, a good regulatory and legal framework. You need institutional framework and expertise of the involved people and institutions, and especially of the ESCOs. And you have to have access to financial and business cases, also to the financial market, but also you need big enough energy efficiency measures that are ready to be done in a ESCO model. If we look to the ESCO market development, we have done it several times studies to main market in the world, and I concentrated in this speech to China. China is the biggest ESCO market in the world, and you see it began in the 90s of the last century, and then the starting point was the establishment of government-owned ESCOs in the market in the period from 1997 to 2006. And starting from this, we have now a very huge ESCO market with about 70 billion in 2017. I don't have newer figures, and about 6,500 ESCOs in China. This success was also result of the work of the Energy Management Company Association, the EMCR, which gives many impulses to the market and helps the single ESCOs to do a good work. A few words to the US market. Also, the US market is successful, but the US market is mainly in the public sector, and it is mainly driven by regulations in the public sector to implement energy efficiency measures there, because of it is starting in the 1980s of the last century, because of the oil price shock, and then it was built up continuously to a functional market with big market players like Siemens and other also international ESCOs. I want to say some words to the types of ESCO projects. We talk in this, or Michael talks to EPC projects with guaranteed savings. This is a normal model in many countries, also in China, US, and in Germany. But in Germany, we have the special situation that the most turnover on with energy contracting is done by energy delivery contracting. In this case, the ESCO runs the heating or cooling system, and it is not as deep energy efficiency measure than in mostly in EPC contracting models. I come to some recommendations. If you want to develop an ESCO market, it is important that you have that you minimize the risks for the market players and have a look on this during the whole development period. It is important to have a clear regulatory framework and protection of the investment, and you have to have good financial instruments, not only access to banks, but also in the beginning funds of the governments to start pilot projects and to develop the first stage of the market. Very important are successful pilot projects in the beginning, in the first phase of the market development. You have to show that this construction is functional for your market with your energy prices and your economic energy efficiency measures in your market. Markets are different. In Germany, you saw in the slides of Michael, we have 38 euro cent per kilowatt hour, and in your market the energy price is much lower, and so you have to calculate in another way around. Important are also facilitators, and to start an ESCO market development, it is very important to strengthen also the demand side. You have to provide information, promote contracting, manuals, guidelines, success stories, workshops, trainings with engineers to develop as an ESCO company, and so on. And you have to show, you have to look to the quality of the supply side, secure quality of energy services, qualification consultants and finance providers. In this case, many countries have certain certification systems for ESCOs, but it is also important to train the bank or the finance system in all, so that this finance sector understand the ESCO system and is able to give loans to the ESCOs or the companies. And very important is provide standardized tool for tenders, contracts, and calculations, minimum in the beginning of a market development. I come to a special situation, the super ESCOs as market catalysator. In China, this was the main driver of the ESCO market. Normally, the government in the beginning capitalize super ESCO with sufficient funds to secure ESCO financing in the public sector. And the role of the super ESCO is providing capacity building and technical assistance to firms wishing to join the ESCO field and provide EPC services. And we have a lot of examples in international with this super ESCOs, but also you in India has a good example with EESL as a world biggest super ESCO in the public sector. And this is very important to develop also a market for industrial use in your country. Only some experience from financing. In this slide you see it's from KfW Bank of Germany. In the left side, that 24% of the companies definitively planned climate protection investment in the next 5 years, and 44% says this is under discussion. And in the right side, you see that the main barriers has to do with financial issues, the payback period, rising financial costs, rising other costs, and profitability of the measures. And this you have to have in mind if you look to the possibilities of financing. Financing energy efficiency normally is more difficult than financing, for example, renewable energy. The burden of financing energy efficiency somehow is that total financial requirements are not clear, and there's no the plausibility of the payback periods of energy efficiency measures also are not clear, and there's no security on side of the financial institutions. And to do something against these burdens, there are some more general strategies to improve bankability. A systematic assessment of energy efficiency potential audits are essential to show what are the potential savings. The incorporation of governmental fundings are important to reduce private loans. Focus should be on standardizable measures so that banks understand these measures and they are not trained in engineering, so keep it simple for the banks. And further on, it is helpful bundling of energy efficiency measures so that auditing is worthwhile for the banks. And finally, I said this before, capacity building in the banking sector. And one example how Europe support the financial situation comes from the European investment banks. These banks give or support local private banks in investing in the energy efficiency sector by credit lines for local banks. and risk-sharing arrangement covering a portion of potential losses in defaulted loans, and advice in introducing financial products for energy efficiency via sector analysis, investment guides, e-learning modules, assistance with the evaluation of potential energy efficiency projects, and software solutions that guide bank staff through the evaluation process. This is my input to you. Thank you very much. Perhaps we have time for some questions if you have. Thank you very much.
Thank you very much. Yes, if you have questions to Carsten, please post them in the Q&A section now. In the meantime, I've seen that there were 2 questions addressed to Michael that you could answer maybe first. The first one, Michael, was to assess the health of the infrastructure in case of absence of energy meters. How many samples or how long do we need the data for to accurately arrive at the baseline? You're still muted, Michael.
Well, I would say it depends, and you should start with at least measurement for a month, better 3 months, to see whether there are big changes on a daily basis, and it should be detailed measurements, so that I see are the days compared, can the daily consumption be compared with each other? Is there a weekend differentiation? Do I have a lot of difference between the month? And I would say the longer the better. Ideally, it would be for 1 year, but I would say from 3 to 4 month measurement, you can start to build up a credible baseline by using engineering tools and to calculate, to extend from this limited time frame to a baseline consumption for a whole year. In my opinion, the baseline should, whether it will be derived by meters or by calculation, should always be for a total year.
Thank you. And there was a second question. In projects where submetering is limited and the ESCO has to calculate the baseline for energy conservation measures itself, what level of uncertainty do you typically accept in the savings guarantee, and how is that risk allocated?
Well, this is, of course, this is part of the ESCO's risks of the savings guarantee, and it's not easy to say, okay, this is a risk level because we use engineering tools, we use experience made over the years. But I would always say there is a risk in the range plus minus 10% per ECM overall, and I need to make sure that not in all areas. I always say I go to the highest possible savings, so potentially I might have a risk of 10% in total. So if I don't take the risk for that is included in the calculation of each ECM to the limit, I might in the end achieve an average level where my risk is, which is kind of risk mitigation. And I could also agree with the customer that to make things a little bit smoother, that I need to guarantee as an ESCO 90% of the savings achieved, and the last 10% are what kind of bonus, or the customer accepts this kind of risk in the project, and I can calculate my project on this basis.
Thank you. Carsten, two questions to you. The first is, in Germany's experience, what was the mechanism that pushed private ESCOs to move downstream into smaller industrial clients? And do you think this is replicable in India, where bank financing for EPC is still very limited?
A good question. Also in Germany, we have a lot of EPC projects, or we are starting in the public sector, and also today we have a bigger market, as I see, in the public sector. If we look on EPC contracts, but perhaps Michael has a better overview to the market situation. He can add some things. And what I see from the more general mechanism how to finance energy efficiency projects in industry, it is important to have clear, standardized measures which are known, which you can add if you could bring together. Yes, we talked about this question with international financial institutions, and they said, yes, you have to bring together more than one measure, more than one company to give the possibility of, for example, international loans to such projects. And I think also in Germany, this is a situation. If we look to the energy delivery contracting, there we have another situation. For example, lighting projects are were run also in industry, and it was easy to make it clear that better lighting is cheaper, and you have short payback times there. I think these measures are easy, perhaps also heating system measures, but more complex measures are very difficult to find external finance also in Germany.
Michael, would you like to add on?
Well, sure. The main obstacle in developing industrial EPC projects is project financing, because the customer usually wants to have it off the books, and he wants to have it with the lowest cost possible, and there is a gap between these two. So I can't get cheap financing if I have to keep it off the books. I, as an ESCO, don't want to have the ECMs on my books also, because it's a problem for my financial security and bankability. And what I know is that a lot of projects that started as an EPC project evolved into single measures implemented. So over the time period. So financing is mostly then coming from the customer, because he says, okay, I have a road here. What can I do? Let's start this year with this kind of project. I have the money. 2 years later, he says, now I want to do the next ECM group. And if the ESCO has been really good and is lucky, the customer goes on with the ESCO with this kind of projects. But industrial customers don't like to talk too much about successful EPC projects because it might tell their competition where their energy costs are going and what their overall costs might be. And my experience is, the bigger the customer or the company, the more likely it is that they go into energy performance contracting, because it's then a repetitive project. Once they have implemented the process for one facility, they can go to another, and so on.
Thank you very much. Being mindful of time, and since we're over time already a bit, I would like to bring this webinar to a close. I would like to thank Michael and Karsten, our speakers, first and foremost, our colleagues in India, as well as everyone participating in this webinar. Please excuse the technical problems. We will share the slides with you via email and try to address all the remaining questions via email after the webinar as well. I would like to wish you all a nice day and thank you again for your attendance. Bye-bye.
Bye-bye.
Well, thank you very much.
Thank you very much. Bye-bye. And we will answer the remaining questions afterwards.
And if you have any other questions, don't hesitate to send them via email. I will try to answer them as best as possible.